Hello sir, myself Jaydev and my team members are Ayush, Abhishek and Siddharth. The topic of our project is art gallery problem. Now let's come to the introduction part. So the art gallery problem is a well studied visibility problem in computational geometry, and it is basically a problem where the main task is to guard an art gallery with minimum number of guards which are enough to observe the gallery. Mathematical model can be represented by a simple polygon uh, where art gallery is a simple polygon, and each guard can be represented by a point in the polygon, and we can say a set S of points is set to guard the polygon if for every point P in the polygon there is some point Q which is in the set S, such that the line segment between P and Q doesn't leave the polygon. So this is basically a mathematical model. Now let's come to the problem statement part. The problem statement is guarding an art gallery with a minimum number of guards who are sufficient, or you can say who as a together can check the whole gallery. And there are many applications of this art gallery problem. It is basically used in architecture and generally used in motion and visibility, placement of radio antennas, robotics, ultrasonography, sensors, and gaming application, and many more. The next part will be explained by Abhishek.
Hello, so I'm Abhishek Kaswa. So, and I'll be talking about one of three algorithms that we have applied in our project, which is triangulation, and how we are gonna apply it in visualization, our visualizer. So, actually, as you know that there are three main algorithms in our project, which is trap polygon triangulation, and then we will use the arm coloring, and after that we will do the polygon visibility for each to view the visibility of each guard. So when the Fisk's proof came out, it he talked about like how we should decompose the polygon into triangles to make things easier, so that we can set a guard in each of these so-called triangles. So that would make things quite easier. And yeah, this is the triangulation that we are talking about. So coming to the code of triangulation, as you can see that there is a function called triangulate poly. What it does that it converts a polygon into a set of triangles that cover the same area as the polygon. There are some conditions like convex and non-convex polygon both can be supported, but polygon vertices must all be in a single plane. Like polygon itself could be in 2D or 3D, but polygon vertices should be in a single plane. And so as an argument it takes as a polygon, which is a sequence of vertices making up the polygon, and each vertex is described as a set of coordinate components. And what it returns is that it will return, as you can see that here, it will return triangle, which is a generator of triangles, each specified in the same format as the input, means polygon. So actually um, this file, it will give many possible triangulation for the polygon, but this algorithm wouldn't specify any attempt to pick a better one. This is, you can say, a flow of this triangulation here. But yeah, so we learned about ear clipping algorithm, where do is that we will search for an ear and then cut it from current polygon. Like if it's a ear or not, we will see, and then we will cut it from the triangle. So in ear clipping algorithm, what we does that we will start with so here, as you can see that first of all we will see that if it's a 3D polygon, then we will convert it into normal, calculate normal, which will convert 3D polygon into normal polygon, and it will return normal vector. And if it's a if it's a 2D polygon, then it will return -1 or 1, depends on the clockwise or not clockwise. So this is the calculate normal function, and after that calculating the normal that we will use later in the function, there are some lists, and we will check that polygon greater than 2, and triangulation failing condition we will also in case of triangulation fails, then we will see that. And after that we are in looped slice, what it does that it will take a start argument, and it will also take as a parameter like length, what length should be, but we want a triangle, so we will set it 3. Then these 3 vertices we will set as triangle, and we will check that if it duplicate vertices is available or not, and if it's available, then we will just delete a part of the polygon list. Okay, so after that we are checking this condition. Sorry, so we are here, we are doing the cross product, and after that um, using the vertices we are doing the cross product, and after that we are doing its dot product with the normal. So this condition which we are doing is for vertices intersection. So we'll check that if it satisfies that or not, and then we will check a function called any point in triangle, and depends on the return true or return false, we will continue on. Like if it's false, then we will continue, and we will delete a part of the polygon, same as we did with duplicate vertex, and we will return the triangle generator. And this is a triangulate poly function. So
So after triangulation, what we'll be doing is we'll be coloring the vertices of the polygon. It is basically 3 coloring algorithm, and what we'll be doing is we will be assigning each vertex a color from pink, green or yellow, and there is a condition that if I pick any 2 adjacent vertices shouldn't be having same color. This is the main um, constraint of the algorithm, and we finally will be choosing the color which is satisfying the condition that total number of vertices divided by 3, this flow value of this should be the cameras, or you can say which color is satisfying this will be taking as the guards or cameras. Now let me tell you what is the 3 algorithm is in depth. So we will be coloring the vertices of the graph using with the method with the depth first search, and we will be maintaining an invariant that all polygon vertices encountered in the triangles have been colored such that no adjacent vertices have the same color. So first we will be starting a DFS on any node, and then we will be coloring the vertices, and with maintaining that invariant that I have already told you. And for an example, as you can see, let's suppose node V is visited from node U. So as we have already colored the 3 vertices of the triangle, so as I move on to the next triangle with the vertex U, so the triangle vertices of this should all 2 vertices of this triangle are already colored, because that 2 vertices are also the part of the U triangle of U. So the only one vertex is left, and that will be uniquely determined. Let me show you a sample code example of answer for this. As you can see here, we have first initialized the graph values, and first we will be defining a function that whether it is safe to color the vertex with the given color. That is basically maintaining the invariant that can we color that the 2 adjacent vertices shouldn't be having the same color. This is for that, and we'll be having a utility function for coloring the graph. What we have used DFS algorithm for this, and as you can see here, it is checking that it is safe to color the vertex or not, and then further it is coloring those, and this is the final, or you can say the main function to color the graph. That it is, and next will be explained by Siddharth.
Hi sir, I'm Siddharth Pokarna and I'll be explaining this polygon visibility part. So we've already seen this triangulation and three graph coloring algorithms, and so from these we can derive that there will be at most three choices of colors and at least one choices of colors to select. Let's say, there are three colors: pink, yellow and green. So we can't have if all the colors are in equal number, so in this we have equal number of pink colors, green colors and yellow colors, then we can select any of the any one color of these three colors. But if we have different number of colors, so then it's not we have to take one solution which is the minimum number, so which will be in the minimum number. So we will have at least one solution and at most of three solutions. And in this polygon visibility part we have certain assumptions, like the guard can see 360 degree. So if there is if this is a guard, then it can see here, it can cover the 360 degree part if it's in the polygon. And one more assumption is there, that we won't have any holes. So holes are basically, this is the polygon, then there should not be another polygon in this polygon. So if this is the polygon, then we can't have a polygon here or here or here. So this is the assumption that we won't have any holes in this. So coming to the part, how to find what is the visibility. So we'll check the vertex. So if there is a guard standing here, then it can see all the vertices. So it can see this vertex, this vertex, this vertex, and the edges which it can't see. So if it can see all both these vertices of an edge, then this edge is completely visible. And so in this case, this is the vertices, this is a vertex which can be seen by this vertex, and this is the vertex which is not seen by this vertex. So this will come in the invisible part, invisible edge. So this part is will come in invisible edge, and then this part will come in invisible edge. So what we'll be doing is we'll have to find the area which which can be covered by this guard. We'll take this 180 degree line, and we'll have to find the intersection point. So if this area is not visible, then we'll have to find an intersection point. So this vertex is visible, so we can create a line. So this is the edge, we will be going through this edge, and we will create a 180 degree line towards this vertex, visible vertex V. And the point where intersection takes place, so from that to the visible part, this will be the area which can be covered by this guard. So let me see, we can see this algorithm. So we'll be given the polygon and the vertices. What is the source vertex, and we'll have a list of invisible edges, so which edges are invisible. And for every other vertex V, so every other vertex from apart from the source vertex, so for every vertex V from this vertex, if V is visible, this vertex is visible, this vertex is visible. So if V is visible, then we will go inside this loop. And if no invisible edges, we can see that both these vertices are both the vertices are visible from this guard. So this is visible edge, so we'll have to simply add this vertex to the solution. And so if no invisible edges, then we'll have to add V to the solution. And if there is an invisible edge, so we can see that this is the invisible edge, so we'll have to find this intersection point. So we'll find the closest intersection point, and if the two edges that are meet on the same side of line, so they should meet in the polygon and should be on the same side of line, then we'll add this closest point of solution to the answer. So we will add this point to the solution, and we'll add this vertex to the solution. So we can see that this is the part which is covered, which will be covered by this guard. And if there is no invisible edge, if there is no this edge, so it's completely invisible from this vertex, so we can add this edge to the invisible edges. So that's what we are doing. So if vertex V is not visible, then we will add that vertex to the invisible edges. Thank you, sir.
Hello, myself Ayush Bhandari, and I will be explaining about the polygon creation. So Polygon is a closed figure that is formed by the straight line segment in such a manner that it creates a closed chain. So there are three possibilities that can happen with polygons. The one is simple, and second one is the intersecting one, and the third is with holes. For this project we are considering the simple polygons. So now the question arises that how we can create a polygon that is not intersecting and without holes. For this we can use the approach that is called the position of 2 points relative to a line. So the idea goes like this, that we create a line segment and we know the equation of that line. So we check that the 2 points, for in this case that is P and Q, whether they are on the same side or in the opposite side. So if they are on the same side, then they don't intersect, and if they are on the opposite sides, then it will intersect with the line. So this is the basic idea. So now let us go through the code. The M position will tell us about the x and y coordinate of the point P that is going to be added, and let us assume that n points are already added, that is they are part of the polygon, and Q is the most recently added point to that set. So we get the idea what P and Q are. Now we need a line. So what we will do is we will iterate over all the points in the polygon in pair of 2, such as 0 1, 1 2, 2 3, and we will check that the points are intersecting these lines or not. If they are not intersecting, that is they are on the same side of that line, then it will be added to the part of the solution and it will tell that these points can be added to the polygon. And if it is not the case, what it will display the message that it can't be added because it will not produce this simple polygon. So now let us go through the execution process. So in this one we can have two types of input, that is one from the file and one with the help of cursor. So initially we have to draw the polygon, and we can see that if I try to point this one, it will simply displaying the message that it can't be produce the simple polygon, so I have to place somewhere else. In this sense we will have to draw the polygon, and we can have as many sides as we want, and when I want to finish the process I have to press enter. Now the polygon creation has been done. Now it will go through the triangulation process. So in triangulation process it will divide the entire polygon in form of a triangles in the clockwise manner. Now the triangulation process has been done. After triangulation, the 3 coloring will take place, and 3 coloring will be done in such a manner that in a triangle there should be different colors. So if in a triangle all 3 colors are different, then only it will satisfy the criteria. So let us go through the 3 coloring. So as you can see that in this situation the color here is green and here is red, so it should be blue. And in similar fashion, when we have this triangle, so blue and green are here, so it should be red in color. So in this sense the coloring will take place. After coloring we will try to identify what is the number of guards. So it is displaying that 7 guards are sufficient to guard the whole library. So it is also telling that there are 2 variations possible for this solution. So one of the variation is this one. It is telling that if you place the guard at these points, the whole gallery will be guarded. And the second variation in which we can place the guard is this one. So we will go through the first variation first, and we will try to identify the visibility area of each guard. So this is for the first guard. This is the range that it can see at a time, and similar fashion second guard, the third, the fourth, and so on. So in the second variation we will do the same process and try to identify the visibility range of each guard. So this is through the cursor. Next I will show you with the input file. For the input file we have to press the space button and select the input file. For input file there is a condition that you should order the points in the correct manner, and it should be possible to create the polygon from that set of points. So for this, the same, it is displaying the two guards are sufficient, and this is their visibility. Thank you.